So at the output of the quantizer, we have discretized the amplitude axis also. So at the output of quantizer, the signal is still not available in pure digital form. The signal has the sample values taken at discrete time instance, and all these sample values are now assigned some fixed levels. Hence, I can say that the output of quantizer is something which is discretized in time domain. It is discrete time signal. At the same time, it is discretized in amplitude domain also. But the output amplitudes may still represented in the form of analog signal. So now how do we give the perfect digital nature to this analog fixed values which we have at the output of the quantizer? These analog fixed values, which are the output of quantizer, are now represented in the form of ones and zeros with the help of encoder. Hence, output of the quantizer, we will be assigning the fixed values to various samples which are coming at the input of the quantizer. These fixed values are also represented in the form of ones and zeros, and that gives us the perfect digital nature to our signal. For example, if the quantizer is, let's say, n-bit quantizer, that means the number of levels in which the amplitude axis will be divided will be m equal to 2 raised to n minus 1, or it can also be m equal to 2 raised to n. That depends upon the type of quantizer we are using. For example, if n is equal to 3, then I may divide the entire amplitude axis into either 7 levels or 8 different levels. Let's say we divide the amplitude axis into 8 levels. In that case, the fixed value which is represented by every level is assigned a group of 3 bits. Because we have 8 levels, I can use all the 8 combinations of ones and zeros. The lowest fixed value can be assigned 3 zeros, and the highest fixed value can be assigned 3 ones, 1 1 1. So that's how every fixed value will be represented in the form of ones and zeros at the output of quantizer. So it is the output of the quantizer which is in the digital form. The last block in the PCM transmitter is encoder. Encoder will provide a specific encoding to the signal. Encoding process is used to translate the discrete set of sample values that we have at the output of quantizer to a more appropriate form of signal which is best suited for transmission over a radio channel. Discrete set of values as a particular arrangement of a discrete events is called a code or a symbol. So for example, in a binary code, 2 symbols used are logic 0 and logic 1. So every discrete sample value will be represented in the form of ones and zeros. When we talk about the digital signal, we want output of the encoder to be represented in the form of ones and zeros. Now there could be various ways in which this can be done. For example, logic 1 can be represented using plus 5 volts and logic 0 can be represented using 0 volts. This could be one way in which you can represent your signal. This is called unipolar representation of the digital signal. Now I can also represent logic 1 using plus 5 volts and logic 0 using minus 5 volts. In this case, the representation is called polar representation of digital signal. So we can design the encoder accordingly. We can have the encoder based on what kind of signal we want at the output of the PCM transmitter. Let us now discuss the receiver part of the PCM. Now you can see in between the transmitter and receiver, where we will basically have the physical channel over which the signal is being transmitted, contains regenerative repeaters. Now what are these repeaters? When the signal travels through the channel, it goes through the attenuation due to the power loss that takes place in the channel. Before the signal reaches to the final receiver circuit, it may happen that it is being greatly attenuated. Now, because the signal which is transmitting is digital in nature, it is possible to regenerate the original levels of the signal. That is because at any given point of time, the signal level will be either corresponding to logic 1 or corresponding to logic 0. And hence, we take the advantage of the very simple nature of the digital signal and we place regenerative repeaters. The function of these repeaters will be nothing but to send the attenuated voltage level back to its original value. I'll give you a simple example in which it can be done.